Okay, just gonna talk about this panel here, which is the master panel, which is the one that's actually controlling each boiler in terms of which boiler fires, how hard they fire, etc., which order they fire in. Typically, you'll see here where it says status, currently it's saying all unavailables. That's just because they're all turned off at the moment, but typically with all the burner switches set to on and all of each boiler in the remote lead lag condition in terms of firing rate, these will all show up as whatever status they're in, running, idle. They flip to unavailable when the master panel no longer can control them for any reason. They're locked out, the burner switch is off, for some reason the boiler is not able to fire. Up at the top it says one boiler is required. Right now that's just looking at water. This is the set point for the system as it's been set, and then the current temperature as we see it, which it was shut off as we were ramping up and didn't hit our off point. So it's still saying one boiler required. Sometimes it would say 2 boilers required. All depends on what it wants to see for the load. Down here we have, entered. So this entered 321 is the order in which they're going to come on and fire. So it's going to first look for boiler number 3 to fire, then it's going to go to 2, and then it's going to go to 1. This control at the bottom is going to be how hard each boiler is firing. So that's the firing rate. If it's 0 and running, then it would just simply be at idle. If it's running and 10%, then it's running at 10% firing. 100%, so on. The percentage of firing is the critical component as to this panel's thinking and processing in terms of, am I okay with 1 boiler or do I need 2 boilers? Where we deal with that is not on this screen. We set up 1. So for the computer to register, do I need 1 boiler or do I need 2 boilers? This is really where you would make any changes to that if so deemed. To make a little bit of sense of this, so we've got, think of it, these are the 2 lag boilers. So the lead boiler is of course whatever boiler's running first, and then lag boiler 1 would be that number 2. If we go back to here, this would be the lead boiler. 2 in the control sequence would be lag 1, 3 would be lag 2. So start point is 80%. What that means is when the lead boiler gets to 80% firing, it's working too hard, it needs some help. Let me start the lag boiler, the first lag boiler. To make it so that we're not cycling boilers on and off a million times, because we could just be sitting there like 79, 78, just banging a boiler on and off, and it would be insane. So what we do is we add a second kind of thought process there, is the first boiler gets up to 80%, and so long as it stays at 80% or above for this box there, 300 seconds, once that timer runs out, then it will start the lag boiler, the first lag boiler. If it spends 1 minute above 80, then dips below, then comes back, and it's like teetering on that edge, it won't start it. It needs to be 300 continuous seconds above 80% firing for the lag boiler to start. So great, we went from, say now 90%, the first boiler firing at 90%, and then comes down to, both boilers would then come down to about 50%. So we then wait 30 seconds at that point. If the stop points would be if both boilers then dip below 50% for an extended period of time, longer than 30 seconds. Same kind of deal with the next lag is if both boilers get to above 80% for longer than 180 seconds, starts the third boiler. When these boilers are firing together, they should maintain the same firing rate. So if one boiler is 50%, the other one's 50%. The only time you'll see it differently is if one boiler is in some sort of a warm-up phase where it's saying, hang on, I'm too cold, I can't get up to that speed yet, just give me a minute. This page is just talking about delays in shutdown, if a boiler's in sequence or not, warm-up minutes, if turned on, these are not turned on. That would just be part of a warm-up cycle that during commissioning we decided not to really use that feature, just to keep boilers hot and warm. But because of our isolation valves keeping the water flowing through the boilers, we decided not to use that. But this boiler in sequence, yeses, just saying like, hey, do we want to use these boilers? Yes or no. So instead of going up to each boiler and hitting off, off, off on the burner switches and then causing all of these unavailables, we could simply come up and hit these to off, and it would then switch them to unavailable. A little bit easier to come up here in one single spot, but the benefit here is with that burner switch on the boilers, you'll keep that isolation valve cracked open and you'll continue to have flow through it, which will keep the shell warm, which is why that whole thought process of keep the valve cracked, the isolation valve cracked, keep water flowing, is why we opted not to do this. So simply coming in, taking these off sequence is a little bit better way of doing things than walking up to the burner itself. It's a little bit easier. So if we want to change the sequence, as in which boiler, I'm looking right over here, which boiler wants to fire next, which one's going to be the lead, which one's going to be the lag. You can see here, boiler 1, boiler 2, boiler 3. The ABC is just a different way of saying 1, 2, 3. And then the current order. So again, if you remember, over here, the entered order is boiler 3 is the first to fire, boiler 2 is the second to fire, boiler 1 is the third to fire. So we see that again here, boiler 3 is the first to fire, boiler 2 is the second to fire, boiler 1 is the third to fire. If we wanted to flip that around and say, make it, 1, 2, 3 in terms of the boiler numbers, we'd come over, hit the change, press, just like we would with any number on any screen. If you see this purple box, and if you want to change any of these numbers, you just hit change, enter the number that you want. You see the number shows up here, and then you come and tap where you want to put it. Same thing, we'll go 2, hit enter, the number shows up here. We put it in, 3, enter, number shows up there. We put it in, and then we have to lock it in and say enter new order, and boom. All those numbers move off to the right, and now we've just changed the order in which the boilers are going to fire. You can do in any order you'd like. If you wanted boiler 2 to start, you can do whichever order that you wanted. This order will automatically change as per the auto rotation schedule, which is apparently currently off. Probably just due to the fact that boilers 2 and 3 were not running for extended period of time due to the gas issues. This would be a good thing to turn on for the long term. Really just hit on, and then every 4 days on the count, like just elapsed time, not necessarily run time, just 4 elapsed days, this will automatically switch over. So we go from running boiler number 1 for 4 days, then we'll run boiler number 2 for 4 days, and so on. We actually would follow this path. We wouldn't change, we wouldn't shuffle the numbers around. We would just go from boiler 3 to boiler 2 being the lead, to boiler 1 being the lead, and then keep running through this sequence. It will automatically shuffle around these numbers. It won't change the order of it. These numbers, we'll just touch on them briefly just to speak about them, but really you'll never have to change them. These numbers are just simply the windows in what it will accept for a local set point. So if I wanted to change it to 160 for the set point, it says out of range, because the lowest possible set point that I can give it right now is 170. Then the highest possible set point I could give it is 237.5. So these, let's talk a little bit about off points, on points, and set points. Just trying to find the best way to view that. Let's say here. So right now we're just focusing on off points and on points. So we have a current set point of 185. We have a current water temperature of 189.4, and then we have ons and offs. So essentially what we're saying here is, look, the number that I want you to keep, ideally in a perfect world, is 185. And the boilers will, if they have the right load, they will fire and maintain almost exactly 185. We almost never work in a perfect world. There's fluctuations in the load. Sometimes it's too low, where it's just, excuse me, times like these, where it's like a shoulder season, it's 80 degrees outside. There's no possible way that we can keep a boiler on indefinitely running at low fire, whatever fire, to maintain. So eventually what's going to happen is, if we turn the boiler down as far as it goes and it's still too much heat, that means that temperature, the actual water temperature, is going to creep up and creep up and creep up. No matter what we do, we can't pull back any further. We're just sitting at the slowest speed. It's kind of like driving in traffic and your foot's not even on the pedal. You got to hit the brakes at some point. So that is our off point. So we don't have enough load to keep at 185 perfect. So we start creeping up. 189, 190, 195. Once it hits 196.1, all right, that's enough. You're too hot. Shuts everything off, and then lets the system just naturally cool down. Just adding whatever load, take that heat out until we get to 187. Then at that point, 187, the boiler starts to kick on, and we start this looping cycle all over again. Very important that this number is higher, the on point number is higher than your set point. Important because it helps reduce the cycles. If it's, you would think kind of logically, well, if it's 185, maybe I want it between, I want the boiler to come on at 180 and the boiler to shut off at 190. That seems to be keeping things at a better temperature than on at 187 and off at 196. That's going to keep it way too hot. Actually, it's not, because the biggest thing about this 187 number is that's when we start to bring a boiler online. It takes 2, 3, it takes several minutes for a boiler to fire, to do its purge, do its checks, its safety checks. It doesn't just flip on like a switch. So we need to give that boiler time to do its thing, and as it's doing its thing for those next couple of minutes, that temperature is just going to keep dropping and dropping and dropping. So by the time the boiler turns on, the water temperature could be very well 180. So we want to kind of give it a little bit of a head start. That's the purpose of having your on point above your local set point. So really, this number here should never go negative. And what this number is instead of, you don't really say, it's the same process of hitting the purple dot and pressing the button to change these numbers. But we don't hit the purple dot and say 187 and then bring it to the brown box. We say 1.1% of the local set point. That's what I want the on point to be. So 1.1% of 185 is about 2. So that's why we have 2 degrees higher than the set point. And then the off is the same thing. So it makes it a little bit simpler so that when you go to change the set point from 185 to say maybe 190, you're only changing one field and all of these other fields follow it in suit. See how it just kind of rolled through and did that calculation? Makes it a little easier when you're just changing a set point. Those numbers are going to follow it. So again here, this is just another field in which we always want to leave it in auto, unless you're doing something, some sort of test or something like that, then you can flip it to manual. But this here is the firing rate of the system. So if one boiler was running, you'll probably see this, max be 30%, because that's all that one boiler can give it. You see high temperatures, low temperatures, current temperature, and again the same set points and on points. Just like any other field and any of the screens, if you wanted to flip it to manual, then you use these buttons to increase or decrease the load. These here, the PNID gains, if you're familiar with them, great. It's just about how do we respond to load fluctuations. I wouldn't mess with these. These are set by the technician when he started it and should be good for the system, for the life of the system, unless major system changes have been made, as in you guys built another wing. But even then, 10 on the P, 10 on the I, pretty much all that we ever really use. We never see any on the differential. So just mentioning them that they're there and that you should never really have to touch those. So we've gone over those set points, gone over that. And then the other thing here is screen select. We can actually pull up the screens for each boiler. We can't necessarily make any changes on the boiler set points and things like that we could when we're at the local panel, but we can bring up each boiler and look at it. We would see if it's firing. We see the individual actual boiler temperatures. We see if the isolation valve's open, see what efficiency it's running at, flue gas temperatures, all that stuff. So again, this is just like a good local kind of first place to visit when you're walking into the boiler room, doing your rounds. And you can flip through, go to each boiler, or come back to screen select, do it there. This is just saying how long each boiler has run since the last sequence change, which was this auto rotation sequence change. Just to give you an idea of how hard a boiler is working during each rotation. These are all saying zeros just because the auto rotation's shut off. And this alarm screen is really only going to be major system-wise, not each boiler. You're not going to see a flame fail or boiler interlock or things like that. You're just going to see power fail if it loses communication with it, low water temperatures. You're not going to see actual boiler individual alarms come through on that point. So I think that's pretty much it for this. Yeah, cool. Okay, this is the one of 2 day tanks in the system. This is the new one that we provided. Day tank 2, or affectionately called the white tank, for obvious reasons. So it's built in a different shape and color as your original, but the intent, the purpose, and the delivery of that purpose is all identical. So what we have is a single tank with a tank containment around it, much like the other one, with the exception of your other one is completely sealed on the top. You're not able to reach your hand in between the 2 tanks. This tank is a 200% containment, so the volume of this main tank is 250 gallons to match your old one. In terms of total 100% capacity is 250. Working capacity is reduced down to 225, which is 90%. This outer containment is going to be a 500-gallon containment. So of course, if this ruptures, you've got more than enough. And then, we even got some if it continues pumping. The theory there is if this inner tank ruptures, the fact that it is included inside the tank, the level is going to equalize to whatever it wants to, including inside the tank. Even though the inner tank has a hole in it, it's still going to fill it at the same level. So if this tank was 100% full, it's still going to find its natural level someplace in the middle, just because of the increased volume. And it allows, the nice part about being open is it allows for any, if these top unions or something like that were to leak, then it would run over and fall into the containment as well. Just like the other tank, we are monitoring it for leaks, which is this leak sensor here. It is just a float type, so a good way to test it is to just flip it upside down and wait a few minutes, a few seconds, and that will trigger the alarm. Just simply, if this fills with any liquid, that little float in there will lift up and cause the alarm. The alarm is wired to that panel there, which then gets relayed to both the fuel oil pump systems, and it gets relayed to the switchboard by the generators. And of course on the BMS and all that jazz. We have a physical level indicator, which is slightly different than the other one. The other one is just empty to full, where this one is inches to empty. Weird way to say it, but the thought makes sense, being at the level is 27 inches. So inches to empty meaning inches to nothing, but that's also just 27 inches off the bottom of the tank. And that was all just set up during commissioning. Some of these connections here, these 5 pipes, this one in the back is your fuel oil fill, and then you have takeoffs and returns to each of the generators. This black pipe goes out to the roof, and it is the vent. Because obviously we're going to be filling and emptying this tank, we need some place for that air to go. If it was a sealed tank, we'd never get any oil in, we'd never get any oil out of it. There are 2 of these blue, brass and blue-headed switches here. They are the level control devices. Reason there's 2 is because there's 2 tanking systems out there, and this is a totally redundant system. So let's talk about the original tank 1. I'm talking about main fuel storage tank number 1 outside with its pump on the top of it. That is looking at this set of floats over here, and there's 4 floats on that stick, 1 for a high level, 1 for a low level, and 1 to turn the pump on and 1 to turn the pump off. So if I were to pull that out, you would see a single stick and 4 different floats at set levels. The top float is set for 90%, which would cause an alarm at the high level, and the next one down, I believe, is set for 85%. Then I believe it is 50% for the pump on. So when the tank gets down to 50%, turns the pump on, pumps it up to 85%, and it should always live within that level. If it continues to drop to 40%, we cause the alarm, and bells and whistles start flying. And then typically, if it goes down that far, you're saying, hey, there's probably something wrong with the pumps. We'll go out to the pumps. Maybe we have to switch the pumps over on the same system, or maybe we just simply say, hey, don't worry about it. We've got a whole different tank system out there. Let's just look at this float for now to buy us some time to troubleshoot that other system. So this float is connected to the new fuel oil storage tank that's out there, the new pumps, the new controller, and it's identical. 100% identical to the other one, where it's got the high, the pump off, the pump on, and the low. And it's just simply going to feed the system from the opposite tank, the opposite pumps. When switching from system to system, of course, there are a couple 3-way valves in the system that would have to get swapped. One notably, which is right here, which is the overflow. So this pipe here is in case, all safeties fail, we want a place for that, and the pump is still continuing, we want a place for that oil to go, which is going to go all the way back down to the storage tank. But we got to make sure that we correctly align this for whatever system is operational at the moment, so that if all else fails, you're only dealing with an overflowing day tank. You're not also dealing with an overflowing storage tank, which would be a possibility. There is an extra tap for whatever you want, inspections, what have you.